3s plus 1 times y. So that's, where was I? This. And then I still have to subtract 1/12, big Y, and set that all equal to x naught. Ew. Ew, ew, ew. 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 Fine. So s plus 1/3. I'm starting to get tired of this problem. 3s plus 1 minus 1/12, big parentheses, y equal to 3y naught times s plus 1/3 plus x naught. So of course we can solve for big Y at this point, right? And that gives us 3y naught times s plus 1/3 plus x naught divided by this thing. I think there's going to be a way to make that prettier, right? Let's see here. So we got 3y naught times s plus 1/3 plus x. I did nothing to the numerator just yet. If I multiply the denominator by 12, maybe that's helpful. Right, so multiply by 12 over 12 was to give us. We get like 4 times 3s plus 1 squared minus 1. Which is fine. Which is, well, yeah, 3y naught times s plus 1/3 plus x naught all times 12. See, this 4 times 3s plus 1 is really squared, right? So that's really 4 times 9 times s plus 1/3 quantity squared. So downstairs what we have then is we've got 36 times s plus 1/3 quantity squared minus 1, which I can rewrite as, I'm tired of this problem, s plus 1/3 squared minus 1 over 36 times 36. So that 36 and the 12 leaves me a third. So the solution is y equals to let's see here. I've got a y naught e to the minus t over 3 hyperbolic cosine t over 6 plus x naught e to the minus t over 3 Now I'm supposed to have a 1/6. I'm supposed to have a 1/6 upstairs, but all I've got is a 1/3. How do I rewrite 1/3 as 1/6? What should I put there? 2? 2. 2. So 2x naught e to the minus t over 3 sinh of t over 6. Yeah. I'm... Yeah, then you solve for x. Could I just, give me just a minute? 1 minute. Y prime, x prime equals to minus y. Y prime equal to x. All right, suppose we have x of 0 is 1, y of 0 is 1. All right, Laplace transform. S big X minus 1 equals to minus big Y. Laplace transform. S times big Y minus 1 equals to big X. I don't want to give you the impression that that's a bad method. That's just a hard problem. It doesn't matter what formalism we use. Numerically, this one is up. So there you go. And then what do? This one's, oh, solve for x. Well, you know, there it is. So this is s times sy minus 1 equals to minus y, which gives us s squared plus 1 times big Y equals to s. And so y is equal to s over s squared plus 1. So that says y is equal to cosine of t. And then at this point, we can go back to the original equations to get x. To get to x, y prime, so x equals to minus sine t. And there you go. So it doesn't, oh no, what have I done?
Not to make it, when you substitute in x back in, you grab the minus 1 on the end. Yes? There should be another minus 1.
Where? Right here?
After that whole thing, there should be a
Schnikes. This minus 1. So that does what? That plus 1, right? And so that gives me plus 1 here, which gives me, thank you for that, sine t, and plus cosine t. Yeah, important. Thank you. I would have noticed that as soon as I went back and checked my initial conditions and they didn't work, which wouldn't have happened because we're done. So yeah, thank you.